International AL P4 October 2022. Question 7. There's an integration by substitution here, and then an integration by part actually with e to the x and cos to x. Very unusual. So here we go. The substitution first. We tells us which substitution to use, and if it didn't, I'd probably use that bottom line just to make it a bit easier. So looking at the limits first, if x is ln 7, then the u is e to the ln 7 minus 3, which is just 4. So that's the top limit, and the bottom one with that from ln 5 gives us 2. Then this fraction that I've got to integrate. The bottom line is just u. The top line, e to the 3x is e to the x cubed, and e to the x is u plus 3. So I'll put that on the top with 4. And I need to sort the dx out, of course. So du over dx is e to the x, differentiating the u in terms of x, which is u plus 3. If I rearrange it so as dx equals, so I'll stick the dx up here and the u plus 3 down here, then I get this. I could write this as du is e to the x dx, like this, and then I was going to pinch one of those e to the x's, stick it with the dx, and make it du. As it turns out, I'll get the same. These u plus 3 terms cancel out, so I'm just left with 4 u plus 3 squared all over u. Now it's in a form that I can integrate, so I can multiply that top line out, and then do it sort of term by term. This 4u squared over u gives me 4u, 24u over u is just 24, and this term is 36 over u. So to do the integration, this is just going to be 2u squared, that's going to be 24u, and 36 ln u. Putting the 4 and the 2 in, that's what I get when I put the 4 in, and I've written it underneath. It wants an exact value, so I'm going to have to do it sort of separately, do the numbers and the ln separately. I've got 2 16s minus 2 4s here. That's I'm going to do 24, and then I've got another 3 24s here. So I've got 72 with the numbers, and this, well, it's 36 ln 4. Take away 36 ln 2, which I could write as 36 ln 4 minus ln 2, so I'm in a bracket, and that just gives me 36 ln 2, because I've just divided the 4 by the 2. The second part is the integration by parts formula. So I need to decide which one is going to be the u and which one's going to be the dv over dx. Well, I'm going to make the e to the x the dv over dx, because I've got to integrate one of them and differentiate the other one. I'd rather differentiate the cos, to be honest, because if I integrate it, I'll get halves and fractions. So I think it'd be easier to do the differentiating on the trig term rather than the e to the x, because e to the x is going to be e to the x whether I differentiate or integrate. So the cos x is the u. So our formula is u times v, u multiplied by v, which is e to the x cos 2x, and then I'll minus the integral of v, which is e to the x, and then du over dx, and that's that u differentiated with minus 2 sine 2x. If I simplify this a little bit, take the 2 out, and then that minus, I can write that as e to the x cos 2x plus 2 e to the x sine 2x. And then I'm going to integrate this by parts again. So I'll put the 2 outside. Again, I'll make the e to the x the dv over dx, and the trig term, the u sine 2x. So u times v is e to the x sine 2x, and then I'm going to integrate the v, which is this integrated, which is still just e to the x, to multiply by the u differentiated, the du over dx, which is 2 cos 2x. So multiplying this by the bracket by 2 e to the x sine 2x, The other term, well, I can take a 2 out, so it'll actually be a 4, and I've got the minus as well, so it's actually minus 4 e to the x cos 2x. And if I look, I've got e to the x cos 2x here, and e to the x cos 2x with a minus 4 in front. So I'd actually take this term over. So I'll have 5 e to the x cos 2x is equal to this. And then, but I want 3 e to the x cos 2x, and I'm going to scale it. I'm going to divide by 5 and multiply by 3 and get this, and put a plus c on it.